boy on Facebook.
68. Probability multiplication rule. This is page 457. We're talking about probability, and when we talk about probability, we're talking about experimental data. If you were to flip a coin twice, you get multiple outcomes. The first coin flip that you did, if you were to draw it out, you have two possibilities, heads and tails, right? If you flip the coin again, you have to account for all the possibilities. So if you flipped the coin once, you got heads, and you flipped it again, what are your two possibilities? So branching off, you get heads and tails. Now branching off, if you had tails, you would get heads and tails. So in essence, there are 4 possible outcomes that you would get from flipping the coin twice.
Heads, tails, tails, heads.
Right. There's 4 possible outcomes represented by the 4 branches that I drew out there. As you just said, Beck, heads, 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 tails, tails, heads, tails, tails. Right? Those are your 4 outcomes. We don't necessarily have to graph that out because that can get irritating. I'll show you why it would get irritating. If I were to roll 2 dice, what are all of my possibilities that I would get? So if I rolled 2 dice, my very first outcome, this is why this can get irritating. Watch this, you're going to draw it. So if I'm going to draw it, they're going to draw it. My first outcome, I would get a 1, I would get a 2, I would get a 3, I would get a 4, I would get a 5, and I would get a 6. The very first outcome.
1, 2, 3, 4, 5, 6 on all of those.
And then, on my second die, there are how many outcomes? 1, 2, 3, 4, 5, 6. And that's going to go all the way down. Okay? Now, the multiplication rule that we're going to do for today, now you can stop there.
Oh, okay.
Because you know you're going to have to write 6 for 2, 6 for 3, 6 for 4, 6 for 5, and 6 for 6. All right, so what would that be? 6 possibilities for each of your times, and there's 6 times. 36 possibilities, right? Because 6 times 6 is 36. There are 36 outcomes. Now, if you look on page 458, there's a chart that lists them out too. Okay? It's a chart that lists them out. There are 36 outcomes that you can get, some more frequently than others. For example, the number 7 occurs the most. And Joe, who likes to play, and his family like to play Settlers of Catan, know that the 7 on the board is a bigger number for a reason. Because when you roll 2 dice, 7 is the number that you would show up the most on 2 dice.
What's that?
Now, what numbers do you not, if you roll 2 dice, would you not get?
1.
You never get a 1. The smallest you can get is a 2, and there's only one way you can get a 2.
1 and 1.
There are multiple ways you can get a 7. Count them.
6
and 1.
2 and 5.
All right?
Or 6.
4 and 3.
A lot of possibilities.
Yeah, that's what I'm.
All right, so now let's make our life easier. So today, instead of having to chart all this stuff out, we can make our life easier. If I were to roll 2 dice at once, how many possible outcomes are there in which the first roll is even and the second roll is even? All right. If I roll the dice, on the first die, how many even numbers are there in 1 through 6?
3.
3 out of 6, right? And on the second die, 3 out of 6 again, right? So I can multiply those 2 probabilities, 3 over 6 times 3 over 6.
36. 9 over 36.
Which is
36.
1/4. Right, because 9 goes in 36 4 times. So I reduce it down to 1/4. Or 1/2 times 1/2. All right? Those are the probability I would get an even number, which is 1/4. All right. So now let's break it out to other stuff. Suppose you had a bag full of marbles, and your bag had 2 red, and 3 blue. You had 2 red, 3 blue marbles in a bag. And you took a marble from a bag, and then you replaced it. Okay, you put it back in. Then you take another marble from the bag. What is the probability you selected a red marble and then a blue marble? So the first time, what's the chance that you pulled a red marble?
1/5.
No, I said there were 2 red in there. 2/5,
2/5.
right? Because there are 5 marbles in the bag. 2 plus 3 is 5. 2 of them are red. So the first time, probability is 2/5. Then you put the marble back in. That's the, in that paragraph, that was the clue. You put the marble back in. You replaced it. So 2/5 times, now we want to get a blue. What's the probability of getting a blue? 3/5. So 2/5, 2/3, 2 times 3 is,
6.
and 5 times 5 is
10.
25 times 5. So the probability that you'll pull a red and then a blue is 6 out of 25 times. You should experimentally be able to do that. All right, so one more. Say you hold a stack of 52 cards, and they're alphabet cards because you're tutoring a kindergartner. Okay, 26 are uppercase, and 26 are lowercase. Okay? You shuffle the stack and select one card. What is the probability that is uppercase?
1/2.
Yeah.
Or 26, 54.
There was a problem like
Oh no, what is the probability it's an uppercase vowel? Let's make that more complicated.
Whoa.
Oh, so
So there's 5
How
vowels.
many uppercase cards are there?
24.
There's 26, I
Or
said.
26.
How many vowels are there?
5.
5.
There's a
So your probability would be 5 over 26, right?
But then we need to get
Okay.
that 5.
5 over 26. So it's 554.
Okay?
Right? Yeah. 552.
If it's an upper, what, now think about the whole deck.
So 5.
How many cards are in the whole deck?
52.
So if you had the whole deck to play with,
5.
it's 5 over 52,
Wow.
right? Not many of those cards are uppercase in a whole deck, are there?
No.
Okay? Half of them are uppercase, but only 5 of them are vowels,
Oh.
right? A, E, I, O, U. We're not talking about the sometimes Y. Okay?
Why is a vowel?
Occasionally it's used as a vowel.
I don't know.
Well, sometimes Y sounds like E. It's a vowel, right?
Fly.
Okay? Like when people call me,
Why is a Y at the end?
like when my friends call me Andy instead of Andrew, Y ends with, sounds like an E, sounds like a vowel, so sometimes it's a vowel.
That'd be cool if you spelled your
Okay.
name with an E.
That's how the girls spell Andy. Andrea, Andy. All right, does that make sense? Okay? That's it.